Hi, my name is Matthew, and in this video we're going to talk about adding and subtracting rational expressions. I would say that the most important little subtopic that's involved in this section is the importance of multiplication by the number 1. And as you know, any number divided by itself is equal to 1. It's also true that if you have an expression divided by itself, it's equal to 1, which is why in the previous video you saw as we factored rational expressions, if we had a factor of something like x plus 3 in a numerator, we were able to cancel it out with a factor of x plus 3 in a denominator, because x plus 3 divided by x plus 3 amounts to a multiplication or a multiple of 1. And you don't really need to include a multiple of 1. Interesting that in the previous video, we were getting rid of multiples of 1, and that in this video we are going to introduce multiples of 1. So if you had a fraction like 3/5 and you multiplied it by 2 over 2, which is equal to 1, you get 6 over 10. Doesn't 6 over 10 just reduce back to 3/5? Absolutely. What's 3/5 as a decimal? It's not equal to 0.8, it's equal to 0.6. And what's 6 over 10? Well, it's equal to 0.6 also. Which is difficult to appreciate when my iPad disappears. Let's do the old unplug, replug, and see if it works yet again. 3 and 2 and thank you. So if 3/5 is equal to 0.6 and 6/10 is equal to 0.6, multiplying by 2 over 2 didn't do anything. And that's exactly right. Well, it did something. 3/5 now doesn't say 3/5, it says 6/10. So it didn't change the value of the original fraction, but it changed what it looks like. It now has a different numerator, and maybe more importantly is it has a different denominator. We're going to be using that over and over again, and you're going to be using it over and over again as you complete homework assignments in this particular topic. But first, the problem that's right, it's not there, it's over there. There it is. Let's do that one first. These two fractions have the same denominator already, and most of you know that in order to add or subtract fractions, they need to have a common denominator. These two fractions already have a common denominator. So I can take the 17 and I can take this minus sign and still have it between the 17 and the 11. That's an 11. There we go. And I can put all of that over my common denominator of b minus 5. I didn't subtract the b minus 5s. I didn't subtract the denominators. I only subtracted the numerators. We could get into a longer conversation about why that is, but we're not going to do that. Just know that the denominator needs to be hanging around b minus 5, and we'll do the arithmetic in the numerator to give us 6 over b minus 5. The same thing happens in problem number 3. We can write this as 8y squared minus 8y, so I've subtracted the numerators, and I'll write that all over my common denominator of y minus 1. Now this problem's a little bit different because we can take this a step further. In the numerator, I can do some factoring, and so I will, just in case. And you'll see that it's going to prove beneficial. The common factor between those two terms in the numerator is an 8y. And if I factor out an 8y from my first term, the leftover is a y. I can confirm that by doing 8y times y and seeing that I get, oh, I don't have to go that far, that I get 8y squared again. And if I factor an 8y out of this 8y, or I should say out of this negative 8y, I'm left with a negative 1. I can confirm that by doing 8y times negative 1 and seeing that I get negative 8y. All over, my common denominator is still there of y minus 1. Now you're seeing why it's important I took the time to do some factoring in the numerator, because you can indeed cancel out this y minus 1 with this y minus 1, giving you a final answer of 8y. So you always want to simplify your answers as much as possible. It doesn't necessarily immediately look like you'll be able to do any simplifying or canceling out, so take it slow and try to keep an eye out for it every once in a while. In our next problem, common denominator is already there, so I'll keep the x squared minus 5x. I'm going to take this plus sign and drop it in right here, plus my second numerator of 6 all over the common denominator which was already there. And then, are you wondering what I'm wondering? Can I factor this numerator and maybe reduce it with the denominator? Could be. Let's see if we can factor it. I think we're looking at a factored form of x minus 2 times x minus 3. Negative 2 times negative 3 makes positive 6, and negative 2 plus negative 3 makes negative 5. So we have factored correctly, all divided by common denominator of x minus 2. Cancel out the x minus 2's, and you've got yourself a final answer of x minus 3. Now I know that I'm kind of cruising through these, so if you need to be pausing or rewinding, I don't blame you. But again, another great illustration of why we spent so much time previously on factoring, because here we need to be using it again. Alright, in our next problem, we do not immediately have common denominators. However, they look pretty similar. I will remind you that the middle denominator is a difference of squares, and if you factored it, you would get x plus 2 times x minus 2. So you can actually replace, if I were taking notes, which you should be, I would copy down this original problem, and then I would rewrite the original problem with this new denominator. The second time you write it down, just change that middle denominator to x plus 2 times x minus 2. And do I want to do that? I guess I do. So let's do that. And if you haven't already started writing, I would indent from the left-hand side of the page. Mine is sort of pre-indented because I've got this other text over here. Yours might not be, but you should indent this one. Let me bring down the 8 over x minus 2 plus x minus 6 over my factored denominator that says x plus 2 times x minus 2 plus my last fraction, the 2 over x plus 2. Now again, these denominators are not the same, but we need them to be the same. We need them to have a common denominator. My first denominator has an x minus 2, but it's missing an x plus 2. I'd like it to have an x plus 2. So I'm going to multiply an x minus 2, an x plus 2 into that first denominator. But if I multiply an x plus 2 into the first denominator, I must also multiply an x plus 2 into the first numerator. So what I'm really multiplying by is, you guessed it, the number 1. And what happens when we multiply by 1? Well, nothing, sort of. It's not going to change the value of our initial fraction, but it is going to change what it looks like. Most importantly, it's going to change what the denominator looks like. Now let's move over to our third denominator of x plus 2. That denominator also needs to have a factor of x minus 2. This denominator now has an x plus 2 and an x minus 2. This denominator has one of each. We want this denominator to have one of each. So let's hook it up. We're feeling generous, and so we give it a multiple of x minus 2. But if we do that to the denominator, we must also do that to the numerator, so that what we're really multiplying is by 1. Multiplication by 1 doesn't change anything, that's why we're allowed to do it, but multiplying by this version of the number 1 changes what the denominator looks like, which is why we want to do it. Now, this denominator, and this denominator, and this denominator are all the same. We now have a common denominator. So, I'm going to rewrite this. I'm going to write numerator plus numerator plus numerator all over the common denominator. Let's see what it looks like. X plus 2 times the 8 plus the x minus 6 plus the 2 times x minus 2. That's all of our numerators divided by the common denominator of x plus 2 times x minus 2. Nice. From here, it's possible that all we have to do is some distributing and combining like terms. Maybe we'll be able to simplify further, maybe not, but don't think for a moment that you're allowed to reduce here, nor are you allowed to reduce here. Nor would you want to. You'd be right back where you started. We just put those there. Okay, don't be canceling those out. Also, you're not allowed to. Mathematically, not just because I said so. Alright, so I'm going to distribute up here 8 times the x and the 8 times the 2 and the 2 times the x and the 2 times the negative 2. So we get 8x plus 16 plus x minus 6 plus 2x minus 4, all divided by our common denominator. There we go, equals, so I distributed here, DIST for distribute. Now I'm going to combine like terms, CLT for combine like terms. I've got 8 x's, plus another x makes 9 of them, plus another 2 of them makes for 11 x's. And let's look at our constant values. I've got positive 16, take away 6 makes positive 10, take away 4 makes positive 6, so that is a plus 6, all divided by our common denominator of x plus 2 times x minus 2. There's nothing that we can do in order to factor this numerator, which would allow it to reduce with our denominator. So this is it. I'm just going to make my 6 look a little bit better, because that's the only thing wrong with my handwriting. And then I'll put a box around this as my final answer. Alright. So the primary tool in solving this problem was multiplication by the number 1. Multiplication by 1 is how we create common denominators. I feel like in the last couple of videos that I've made, I have said, use a dry erase marker and write that on the bathroom mirror, or write it on a piece of paper and stick it on the wall over your desk, or whatever it takes. But this strategy of using multiplication by 1 is 100% the key to success in being able to add rational expressions together like this. It's the key to success adding fractions together, period. Even if you were adding 1/3 and 2/5, I still need to create a common denominator of 15. I'd still have to multiply this fraction by 5 over 5 and this fraction by 3 over 3 in order to make my common denominator of 15. How did I do that? Multiplication by 1, multiplication by 1. So you've been using this, or you were supposed to have been using this, since you first learned about adding fractions together. Now would be a great time for you to commit it to memory. It's time to remember that creating common denominators is facilitated by multiplication by 1. It applies to subtraction also. I will work through this one also fairly briskly, and then I'm going to send you off to do some additional practice and to do some multiplication by 1. So this is equal to 4x over, let's factor the denominator, x minus 3 times x minus 2 minus the 16 is still up here over x minus 2 times x minus 4. So far we have a common factor of x minus 2. However, the first fraction is missing an x minus 4 in the denominator. The second fraction is missing an x minus 3 in its denominator. So it's time to get generous. Let's multiply this first fraction by x minus 4 over x minus 4. And let's multiply the second fraction by x minus 3 over x minus 3. Voila! Now we have common denominators in both fractions. And we made that happen using multiplication by 1. The number 1 and the number 1, they look a little bit different, but clearly they're both equal to 1. Alright, so now let's put these numerators together. I've got an x minus 4 times the 4x, don't really need parentheses around the 4x, minus the 16, which is being multiplied by the x minus 3. It's all over our common denominator of x minus 4 times x minus 3 times x minus 2. I'm not going to rewrite that over and over again. I know what goes in those parentheses. I'll fill them in at the end. Equals, let's distribute in the numerator, dist. 4x times x makes 4x squared. 4x times negative 4 makes negative 16x. Negative 16 times x makes minus 16x. And the negative 16 times 3 makes a positive 48. Negative times negative makes positive. All over. My common denominator is still there. Don't worry, we're not going to let it wander off. Now let's combine like terms. In the numerator, these two middle terms of negative 16x are going to combine, so we have 4x squared minus 32x plus 48 all over our common denominator. And now, is there any factoring that we could do in the numerator that might end up providing us the opportunity to reduce with the denominator? Maybe. I see a leading coefficient of 4. 32 is also divisible by 4, and 48 is divisible by 4. So let's factor out the 4 initially and just see what it is that we're working with. So we factored, and now x squared minus 8x plus 12, can we factor that? And minus 2 times minus 6 makes positive 12, and minus 2 plus minus 6 equals negative 8. We can factor this. Factor again. Equals, there's the 4, there's an x minus 2, there's an x minus 6. I think it's time to write in our common denominator. In what order did it appear? Doesn't really matter. X minus 4 times x minus 3 times x minus 2. And now we can reduce. What we see is that in the numerator there's an x minus 2, in the denominator there's an x minus 2. Those go away, and I'm going to write my final answer as 4 times x minus 6 over x minus 4 times x minus 3. You could be asked to distribute in the numerator and FOIL in the denominator as a multiple choice option. You might have to do that multiplication, but I would say it's pretty typical to go ahead and leave this in factored form. That was a heck of a problem. I would not hesitate, if I were you, to give it a day, go back and rewrite this initial subtraction problem, and try this process again and see if you can get the right answer on your own. Write down this problem onto a separate sheet of paper, leave the My Solution process paused, see if you can do it. If you get stuck, push play. Let me catch up with you. If you think you've got a final answer, just fast forward to the end and check your answer against mine. And you can use that strategy of using problems that are worked out in videos, not just with mine, but any reputable instructor who's out there creating videos, do the same thing. Take their example problem, work out the solution process for yourself, and check your answer against their answer. I hope that's helpful, and I hope you have a newfound affinity for multiplication by 1. Thanks so much. See you next time.